All right, still hungry? Welcome back. Get yourself an Orange Cranberry Club from McAllister's. All right. Now we're going to go over some, typical test questions. Two concentric circles we'll call that good enough, have radii of 5 and 8. I'm not going to draw them yet. Within the larger circle is a chord that is tangent to the smaller circle. What is the length of that chord? Okay, so that is the radius of the smaller circle, and it is perpendicular to the tangent. That is 5. This is the radius of the bigger circle, and that is 8. We're looking for the blue line. Well, let's just settle for that. Okay, so we'll say 5 squared plus x squared equals 8 squared. X squared is 64 minus 25. 39. Thank you. So x is radical 39. Divisible by 3, but that doesn't exactly help us. And so the blue line, the chord, would be 2 radical 39. Okay, a square is inscribed in a circle with a radius of 10. An equilateral triangle is also inscribed in the same circle. Find the area of the square and the triangle. Well, let's just draw two different pictures and focus on one thing at a time. All right, so there's our square inscribed in a circle. The radius is 10, so then what did I just draw? I just drew the diameter, and that's 20. And how do I get from the hypotenuse of a 45, 45, 90 triangle to one of the legs? I divide by radical 2, and that's equal to 10 radical 2. And if you didn't understand that simplifying, then you got to go back to Chapter 9, Simplifying Radicals. Okay, so one of the sides is 10 radical 2. So the area of the square is 10 radical 2 times 10 radical 2, which is 100 times 2, which is 200. Okay? Equilateral triangle. That is 10. Okay? I've just created a 30-degree angle right there. Does everybody understand that? So, if I drew this down to here, I have the hypotenuse. This is the short leg because it's across from the 30. How do I get from the hypotenuse to the short leg? I divide by 2. So this is 5. And then what is this? 5 radical 3. Okay, so now I know that the base of our 30, 60, 90 triangle is 5 radical 3. To save you confusion, I'm going to draw this picture, and then I'll recopy it. We're trying to find the area of the blue triangle. To do that, I need to know the base and the height. This is what I need to know. I know that this is 5 radical 3, and that this now is my 30-degree angle. So how do I get from my short leg to my long leg, which is the altitude of the triangle? How do I get from the short leg to the long leg? Multiply by radical 3. What's 5 radical 3 times radical 3? Well, it's 5 radical 9. And what's 5 radical 9? That's 15. Okay? So, the area of the blue triangle will be 1/2 times the base, which is 10 radical 3, times the height, which is 15. So it's 5 radical 3 times 15, which is 40, no. What's 5 times 15? 75 radical 3. Would you expect the square to be bigger than the equilateral triangle? Absolutely. What happens to these shapes as the number of sides increases? They start to get closer and closer and closer to looking like a what? To a circle. You got that? Because that actual topic is also on the test. Okay, next one. Two segments tangent to a circle form a 60-degree angle where they meet at point P. So this is your ice cream cone question. Tangent, 60 at point P. Okay. Each segment has a length of 6. How far is point P from the circle? Now keep in mind, not from the center of the circle, from the circle. So they're actually looking for the length of that segment. Does everybody understand that? That pink segment from here to here is what they're looking for. Okay, once again, we've gone over this a lot in the last 2 days, so it's obviously a very critical concept. What's the relationship between the radius and the tangent? Perpendicular. That's really important. And so we know that this is 6, and we also know, well, let's see, two segments, tangent to a circle, form a, oh, it's 60. It's 60. Got it. So this is one of those questions that we would have to use trig, but we don't because it's a special right triangle. So notice, is 6 the long leg? This is a 30-degree angle, and this is a 30-degree angle. These two triangles are congruent to each other by SSS. So is 6 the hypotenuse, the long leg, or the short leg? It's the long leg. This is an upside-down right triangle. So this line is the hypotenuse. So how do I get from the long leg to the short leg? I divide by radical 3, and 6 divided by radical 3 is 6 radical 3 over 3, which is 2 radical 3. So this radius is 2 radical 3. So what is the hypotenuse? How do I get from the short leg to the hypotenuse? Multiply by 2. So let's see, from here to there, let's just call this A. PA is equal to 2 radical 3 times 2, which is 4 radical 3. But that's not what we want. We want P, let's call that X. We want PX. So what will PX be? 4 radical 3 minus what? 2 radical 3. And so the answer for PX is better to be written as 2 radical 3. Not 2. 2 radical 3. Remember, 4x minus 2x is 2x. The radical 3's do not cancel. It's a factoring issue. Okay? Good. That was a hard question. So if you made it through that one, you're doing great. Find the radius of a circle inscribed in a 5, 12, 13 triangle. I'll start with the circle because it's just easier to draw it that way. And then I know that this triangle, what kind of triangle is it going to be? And I don't think you could do this question if you didn't realize that it was a right triangle. All right. What kind of problem is this? Walk around. Do you see it? It's 3 different ice cream cone problems. So this right here is what we want. What angle's formed here? This is like the 10th time we've talked about this today. What kind of angle is this? A right angle. What kind of angle is this? So that just makes that little thing right there a square. Okay? Let's call this 5. Let's call this 12. And let's call this 13. So what will I call this little section down here? That'll be 5 minus r. So what's this? 5 minus r. Now, this whole thing is 13, so what is this portion? 13 minus, and don't forget your parentheses, and that is 8 plus r. Do you get that? So this is 8 plus r, so this is also 8 plus r, and now we can say that 8 plus r equals what? 12. So 2r is 4, and our r is 2. Got it? Now, I've said before you can start anywhere you want, and you can, but be careful. If you would have called that r, you would have not have found the radius of the circle. You'd had to plug it in down here. So I found the radius of the circle because I started by calling that r. All right, I don't know how many we have left. Tangent segment PT measures 8 centimeters. The radius of the circle is 6 centimeters. Find the distance from P to the circle. Well, let's just start with a circle. Okay, tangent segment PT is 8 centimeters. The radius is 6. Find the distance between P and the circle. That's what they want. By being able to draw in multiple colors, I can show you this so much better. But you guys don't have that opportunity in pencil, so you have to kind of see it that way. Because what are these black segments? So how much are they? And what kind of angles formed here? And if you're really good, you don't even have to do anything. You know the answer is what? It's 4. And that's from 6, 8, 10. So we know the hypotenuse is 10, and therefore that must be 4. And then once again, the distance between P and the circle is 4. Okay? That's it. That's the terrible drawing that we ended the day with. All right, good luck to you guys. Thanks for tuning in. Have a good night.